Good morning. In this new video on energy and enzymes, we are going to know why, or to repeat the explanation on why the change in Gibbs energy, which is delta G, is considered negative in case of an exothermic reaction. So why is delta G negative in exothermic reaction? First of all, let's remind you of the fact that delta G represents the change in enthalpy, and that enthalpy is nothing but the internal energy plus the value that is pressure multiplied by volume. So delta G at a constant pressure and a constant volume will be directly proportional to the internal energy. So if we delta G is directly proportional to enthalpy, and enthalpy is directly proportional to the internal energy. So when we put enthalpy on the y-axis and time on the x-axis, so enthalpy here, the change in enthalpy will represent the change in delta G or the change in Gibbs energy, and is related to the internal energy. So if the internal energy of the reaction is higher than the energy of the products, then there will be heat that is lost, and the products therefore have a lower internal energy and a lower enthalpy H. Then notice that enthalpy is H. As you can see here in the reaction, in the equation, we have enthalpy H equals the internal energy plus PV. So if PV, which is the pressure multiplied by the volume, is constant, then H, or enthalpy, will be directly proportional to energy. Now this heat will be lost, and therefore the products will have lower enthalpy than the reactants. Again, here you can see that enthalpy equals the internal energy plus the pressure multiplied by the volume. We cannot measure enthalpy. Why? Because the internal energy that the components or the molecules contain cannot be measured, is not accessible, but we can just detect changes in enthalpy. So the release of heat here is an indication that there was a change in enthalpy, that there was delta H. And we can deduce, of course, from the graph that the energy of the products is lower, or that the energy or the enthalpy of the reactants is higher, and the difference is detected as heat that is released to the environment. Actually, we can move on